Hello, my name is Ron Smith, and I am the principal investigator on the Phase 2 effort for topic N192-082, the TALOC-enabled mobile phase array antenna technology project. With me today is Bill Ziegler, our program manager. Hello, Bill.
Hello, Ron. It's exciting to have this opportunity to talk about our groundbreaking free space optical enhanced phase array antenna technology. We would like to thank our sponsors at NAVAIR, PMA 265 for their continued support for our project.
The first thing you need to know about our technology is the optical medium and how it makes a mobile distributed phase array antenna possible. We will get into the details later, but optics provides the kind of precise measurement and broadband communications needed to form a dynamic map of the mobile RF node positions in free space. Additionally, the optical system will disseminate the signal information that is carried on the RF wave.
First, a little bit about our company. 4S Silversword Software and Services, LLC is a native Hawaiian organization-owned NHO, 8A, and Hub Zone company. Our intellectual property creates a platform for our team of physicists and engineers to build upon through our current SBIR contracts. We are currently located in the UMBC Technology Incubator in Catonsville, Maryland.
Don't forget to mention that the phase array development is based upon our patented through-the-air link optical component, TALOC, and our patent pending airborne mesh network forming phase array antenna technologies.
Thanks, Ron. That's a good point. The slide shown provides more details about our patents, key resources, and facilities.
Bill, what is the Navy's interest in this technology?
Well, the ability to communicate with pinpoint accuracy in an RF-denied environment has been one of their hot buttons for a while. The ability to form a flight of UAVs into a phase array antenna has never been successfully achieved. This is where 4S comes in. Our FSO technology is the enabler that has been missing from previous efforts. We have received interest in our technologies from several programs of record, including Joint Strike Fighter, PMA 265, and others. The slide has more information on the Navy's interest.
The picture on this slide shows two flights of UAVs formed into phase array antennas and communicating across an extended distance. Additionally, one of the UAV swarms is directing a pinpoint beam to a forward deployed fire team on the ground. Our technology uses optically connected RF nodes to provide a complete solution and enable the degree of accuracy required to initially align and maintain alignment in a dynamically changing environment.
Ron, does this system convey assured position navigation and timing, secure communications, and global navigation satellite system denied environments?
Yes, that is a primary benefit of this technology. In this example, RF wave alignment starts with RF transmission from the signal seed UAV to all UAV units in an ensemble, represented by the black waves. The red waves represent a beam formed by the ensemble that is precisely directed toward a ground asset.
Couldn't this transmission from the signal seed UAV be an optical transmission as well?
Certainly, as long as the optical signal is transmitted to all of the UAVs. Following the signal seed transmission, the distributed antenna formation proceeds in steps. Step 1. Generate a first-order three-dimensional map based on TALOC inherent range and angle measurements. Step 2. Improve map accuracy based on range measurements incorporating sub-bit phase measurement. Step 3. time synchronization using combined optical RF measurements completes the phase-coherent RF wave transmission capability.
So, Ron, how are we going to demonstrate a complex synchronization of distributed UAVs in a Phase 2 demonstration?
In the interest of making the Phase 2 demonstration affordable, we plan to use 8 tripod-mounted RF transmitter nodes moving in a quasi-random pattern, forming an irregular array simulating random aircraft movement. Optical tracking will provide data to keep steady RF signal on the command receiver. In Phase 2.5, we will use fixed-wing UAV carried nodes in a station-keeping flight pattern similar to the pattern in the illustration.
Ron, can you tell us what benefits the Navy will gain from this phase array technology?
This Navy capability extends information transfer to near and far ranges, provides APNT to all communication partners, and is undeterrable. The low cost of individual platforms effectively dares adversaries to expose anti-aircraft assets. Optically connected airborne swarms form a maneuverable phase array antenna that maintains broadband communications in all weather and continues operating seamlessly in RF-denied scenarios. Individual elements may rotate in and out of mission groups to sustain 24/7 air presence and close surveillance. Bill, you have been talking to the Navy program offices. Have you received any actionable commitments?
Our current sponsor for this and our FSO effort, PMA 265, the FA-18 group, as well as PMA 268, MQ-25 group at NAVAIR, have committed to supporting us for a Phase 2.5 effort that will further develop the FSO technology utilized in this project. We're continuing to engage them to commit to Phase 2.5 support for this application. The slide lists the PMAs we're currently approaching for support. In addition, the U.S. Army C5ISR Command, APNT Group at Aberdeen Proving Grounds, has expressed interest in the development of this technology for their troops on the ground. Ron, what commercial markets could benefit from our phase array work?
Well, Bill, there are 2 opportunities that come to mind. In the telecommunications arena, we envision an opportunity relating to low Earth orbit internet services. We propose replacing single large RF antennas with a cluster of optically connected nodes, where broadband data streams may be bidirectionally focused in parallel to highly localized surface receivers. This capability approaches the flexibility afforded by fiber optic networks while avoiding the last mile cost and security vulnerabilities of these systems.
That is interesting. What is the second opportunity?
The second opportunity we see is large area terrain mapping using sensor UAVs arrayed in a line along the direction of flight. Combining phase array antenna and side-looking airborne radar technology offers resolution that is competitive, if not better, than LiDAR.
Following the successful development, what important long-term use cases do you envision?
Well, replacing the UAV shown in the image with a swarm holding station above a carrier fleet would enable directed, long-range RF communications to other fleet elements. The use case previously described in slide 4 shows ground forces receiving the information they need through focused RF directed beam communications.
At 4S, we want to hear your ideas. How can our technology help meet your needs? Please reach out using the contact information provided here. We are ready for technical and business dialogue at your convenience.